In previous lecture, I discussed set operations like union, intersection, difference and complement. Today I will discuss set identities. So first one is identity law. A intersection universal set will be A union phi will be A. So any set union with empty set will be that set, and any set intersection universal set will be same. So let this is A, this is our universal set. Now A intersection U, A is already inside universal set. A intersection U will be A and A union phi will be A. As phi is an empty set, phi contain no element, so it will be A. Next one is domination law. It's like any number multiplied by 0 will be 0, means 0 dominant over multiplication. So here A union universal set will be U and A intersection phi will be phi. So any set intersection with empty set will be empty set. Here A intersection phi. Let A contain 1, 2, 3. Now 1, 2, 3 intersection empty set. It will be empty as both set no element are common. Here no element, here 3 element, but in both nothing is common, so it will be phi. And A union universal set, it will be universal set. Let here 4, 5, then A union universal set, it will be 1, 2, 3, 4, 5. Next one is idempotent law. So A union A will be A intersection A equals to A. So any set union and intersection with same set will be same. Next is complementation law. A complement will be A itself. When we are doing 2 time complement, it will be itself. So A complement over complement, that is equivalent to A. Next is commutative law. A union B equals to B union A intersection B equals to B intersection A. Union and intersection are commutative. We can switch the position, but difference is not commutative. A minus B is not equals to B minus A. Next is associative law. A union B union C equals to A union B union C, and A intersection B intersection C equals to A intersection B intersection C. We can shift the bracket. In case of union and intersection, we can shift the bracket. That is our associative law. Here previously bracket was in B intersection C, here A intersection B. I already discussed all these in logical equivalence of first chapter logic. These are same. There we just use the and or you can say conjunction disjunction. Here we are using union intersection. Next is distributive law. A union B intersection C equals to A union B intersection A union C. So A union B intersection, then A union C. Next A intersection B union C, that is equivalent to A intersection B union A intersection C. Next is De Morgan's law. A intersection B complement equals to A complement union B complement. Here just mark this operator is changing. Previously it was intersection, now it is union. And A union B complement equals to A complement intersection B complement. Here it was union before, now it's intersection. It's same as De Morgan law for and or. Next is absorption law. A union A intersection B equals to A. Let one set be A, this is another set B. So A union A intersection B, this part is our A intersection B. This is our A union, this intersection part, that will be A itself. A intersection A union B. Let me do another diagram for this. Let this is A, this is B. Now A union B. A union B are these all whole part which are common between A and A union B. A union B also contain A, So A intersection A union B will be A. Next is complement law. A union A complement equals to universal set. This is our A, this is our universal set. A complement is this part which are not in A but in universal set. Now A union A complement, that will be whole universal set. Next A intersection A complement will be phi. This is our A intersection A complement. A complement is the outer part which are not in A but in the universal set. So is there anything common? No. So A intersection A complement will be phi. I already discussed all identity in logical equivalence of first chapter mathematical logic. Just go through that, both are same, just name are different. Here we used union, intersection, there we used and or you can say conjunction, disjunction. In next lecture I will discuss some proof of these laws. If today lecture is helpful for you, please like, share and subscribe. Thank you.